So welcome everyone. My name is Heather Benway and I manage the Ocean Carbon and Biogeochemistry Project Office, which is hosted by the Woods Hole Oceanographic and receives funding from NSF and NASA. I want to acknowledge my speakers and co-conveners today, which are listed here on the slides, as well as all of the sponsors and data repositories and ship-based time series programs that are supporting the work that will be presented here today. You can see them all below, including NSF and EarthCube and EuroSea and BICO-DEMO and the National Ocean Data Center. We'll be referencing pretty much all of these here today, including a couple of use cases from HOT, the Hawaii Ocean Time Series. So really fortunate to have all of these folks here with us today. So sustained ship-based ocean time series have really been a cornerstone of oceanographic research, but a lot of the individual time series programs are built around very specific operational and science goals, and a lack of coordinated universal data and metadata reporting standards, combined with a lot of disconnected data repositories and data management efforts, have really impeded our capacity to conduct synthetic research across time series to analyze regional and global marine ecosystem trends. The goals of today's presentation, today's community meeting, are to really introduce you to a new NSF EarthCube-funded research coordination network for ship-based Marine Ecological Time Series. It's called the METS-RCN, and we are aiming to provide an accessible overview with some 80s pop culture references of why fair data solutions are needed for ship-based time series. We will also be sharing a few examples and applications of semantic approaches and controlled vocabularies with oceanographic data sets. And then we want to have plenty of time for some Q&A and discussion with our speakers afterwards. You've already probably seen the link in the chat to the Google Doc to help us collaborate and share ideas throughout. You can also use the QR code or the shortened URL here to get to that document. There are a lot of resources in the document that help provide some background for the METS-RCN and a lot of the efforts that we're doing here, talking about here today. If this is an effort you'd like to stay involved with or stay informed about, please add your name to our list. We have a growing email list, and if you're not already on it, I'd be happy to add you to that email list. So the agenda and speakers for today's event are listed here. I'll give a quick overview of the METS-RCN, and then I have a pre-recorded presentation from Adam Shepard of BICO-DEMO, the Biological and Chemical Oceanography Data Management Office, which is based here at Woods Hole Oceanographic, where he will introduce the concept of FAIR. For those of you who are not aware of what FAIR means, it's findable, accessible, interoperable, and reusable. And it is really the foundation for how we want to move forward with providing data sets for oceanographic research. So I'm going to share Adam's presentation, and then Adam is here for Q&A for after the talks are done. Then we're going to move on to some data use case highlights from Nico Lang, Fernando Carvalho Pacheco, and Justin Buck. So for many of the physical and biogeochemical parameters measured by time series programs, there are controlled vocabularies that are being used by other observing programs and networks that can be leveraged. We're not really looking to recreate the wheel here, reinvent the wheel. But for a lot of the biological parameters that make these time series programs uniquely valuable, and some of these are shown here in red, there's really been very little coordination around community adopted data or metadata reporting standards. So there's a long history of international coordination and community building in support of ship-based ocean time series programs. And you can see the Ocean Carbon and Biogeochemistry Project Office has worked with numerous collaborators, different time series, different international entities and programs like the International Ocean Carbon Coordination Project, the International Group for Marine Ecological Time Series, and also EarthCube, including efforts focused on methods intercomparison and statistical trend analysis across globally distributed time series data sets, and gatherings and publications to really highlight the utility of these data sets and set a vision for the future. There was actually a Frontiers paper published in the OceanObs 19 special volume of Frontiers in Marine Science. And that paper is, I think, linked right from that Google document. Today, I really want to focus on the more recent efforts and activities and products that have really focused on data and fair data efforts. These are highlighted in orange. They've really helped catalyze this research coordination network that we have today. So in September of 2019, there was a small NSF EarthCube sponsored workshop that was held to conduct a data cyber infrastructure gap analysis for ship-based ocean time series, and really provide a forum for discussing these key issues and barriers surrounding data discovery, access, and interoperability. And we held this meeting in Hawaii in conjunction with OceanObs 2019, because we knew that a lot of the players would already be there. And we really used the FAIR construct as a guide to frame the issues we were discussing. And you could see some of the major discussion topics that we covered highlighted here. And there's probably a link to that report. I believe there's a link to that report in that Google Doc, but if there isn't, I'll make sure you get one. So some of the key recommendations that emerged from that workshop are listed here, and you can access the full report via the DOI, which is also, yeah, the DOI is definitely in our discussion notes now that I remember. But we really wanted to focus on a pilot data product, you know, starting with a limited set of time series sites and variables. We really wanted to think about finding some overarching international leadership group for ship-based ocean time series, not just looking at data, but looking at all of the issues that tie this international network of time series together, so that we can enable the more synthetic scientific analyses across time series data sets, as opposed to just working at one individual time series site. There's tremendous value in this. We wanted to think about mechanisms to broaden both users and applications of ocean time series data. But in the near term, we wanted to find a prolonged funded effort. We wanted to find a way to get funding for a prolonged effort to develop fair data solutions. And that's really why we wrote this proposal to get this research coordination network funded. So as a direct outgrowth of the workshop, with co-PIs Danny Kincaid, also from Bico Demo, and Angelique White, the lead PI of the Hot Time series, we submitted a proposal to NSF EarthCube in 2020 to establish a research coordination network that would extend these cyber infrastructure discussions to the broader community of data scientists and managers, ship-based METS data producers and users, and representatives of complementary ocean observing programs, because we're certainly facing a lot of similar challenges as other ocean observing networks and efforts. So the METS-RCN has the following overarching objectives. We want to bring together members of the oceanographic, data science, and informatics communities to discuss and identify fair data solutions for ship-based time series. The key here is to leverage that which already exists. As I mentioned before, there are a lot of controlled vocabularies out there for oceanographic variables. We don't need to completely start from scratch here. We want to devise solutions in collaboration with other ocean networks like Marine Biodiversity Observing Network, MBON, and work towards a common goal. You know, a lot of emerging biological observing networks are grappling with the same problems and challenges right now. And if we're all working towards a common solution, that solution will be much more applicable thereafter. And we're really trying to engage the expertise of data scientists and curators in this process to reduce the burden on the ocean scientists and technicians who generate these data sets, but don't necessarily have dedicated funding or expertise to investigate and pursue fair data solutions. We also want to engage broader METS data users, including modelers, educators, decision makers. We want to facilitate broader applications of these data sets so that we can maximize our return on investment in these kinds of programs. And finally, we want to build community capacity for METS data analysis, statistical methods, data model integration, being able to ingest, analyze, and integrate METS data with other disciplinary and cross-disciplinary data to accelerate scientific discovery. Making these data so that they can be absorbed and they can be ingested and be used more readily in models. These are all challenges that, if we could get over those humps, would really increase the use of these data sets. So the METS-RCN, I will say, it really, so I am from the Ocean Carbon and Biogeochemistry Office, and we have a history of supporting Ocean Time Series scientific activities, methodological intercomparisons, as well as this data work that we're trying to do. And I've also just been really personally committed to trying to find a vision, like what does the next decade for these programs look like, and how can we maximize the use of these really valuable and unique data sets. So I have a project office here in Woods Hole. OCB project office has amazing support and logistical support and infrastructure in place already to help spin something up here to provide the coordination needed. We are also leveraging the expertise of the Biological and Chemical Oceanography Data Management Office. That's also here in Woods Hole. And we also have a member of, a lead PI and member of the ship-based Ocean Time Series community, Angelique White from the Hot Time Series. So as a team, we feel like we can leverage resources we already have and access we already have to the user community, the generator community, the data community, to kind of be able to implement all of these activities and realize the goals that we have. So we're currently in the first phase of the RCN, which is really a lot, not as far as I really wanted to be, but the pandemic has really kind of, I don't know, put a dent in our plans. We haven't been able to gather in person, and it's just been slow going. Everybody is really overcommitted and busy. So much of the work and coordination we've done thus far has been virtual. We have been focusing largely on establishing leadership and spreading the word throughout the community. We have a web presence now. We have had some meetings and presentations with partner networks. We had a town hall at the Ocean Sciences meeting, and we wanted to follow it up with this free event in case people did not attend Ocean Sciences, to try to capture a broader range of perspectives and ideas about how to start tackling this problem. We have assembled leadership for the RCN, including a steering committee to provide oversight of all RCN activities, and a METS data working group to oversee development of key components of a fair data model for METS. And that includes aligning with existing vocabularies, developing metadata reporting standards, a minimum set of metadata reporting standards, and starting to broach the issue of data citation practices and making sure that the collectors and generators of these data sets are getting credited where credit is deserved. So the two RCN leadership bodies I mentioned here, the steering committee and the METS data working group, they really comprise expertise in oceanography, data science, statistics, Earth system models, informatics. The membership spans a mix of large and small US and international ship-based Ocean Time Series programs and data repositories. So the fair data solutions is something that we are really starting to broach with the METS data working group. It's mostly been meetings among both the METS data working group and the full steering committee so far, but they're really starting to spin up efforts now. We anticipate that this working group will operate throughout the entire duration of the RCN, working with other groups and networks to devise fair practices and recommendations for different parameter sets as they're generated. We aim to work especially closely with GOOS BioEco Panel, MBON, the METS-RCN, and the Ocean Best Practices System as we aim to develop standards for biological parameters. We'll also need to engage a broad faction of the international ship-based time series community, data generators and users, to share and vet any recommendations we come out with. We aim to develop a compilation of fair data practices for ship-based ocean time series that could be archived and updated as needed in the Ocean Best Practices repository. METS data working group members have started discussing vocabularies and semantic approaches. We'll actually present a couple of use cases here today. And in addition to improving interoperability through controlled vocabularies and other semantic approaches, we aim to build consensus on metadata reporting standards, particularly for newer biological measurements. The next phase of the RCN will focus on broadening METS data user communities. This will involve the development of a couple of regional METS user networks. These will be pilots. This is just an idea we have, and we'd like to initially build these around a couple of well-established ship-based time series programs to build and strengthen links to interested stakeholders, which might include researchers, modelers, resource managers, educators. Through this effort, we're aiming to identify the unique information needs of different users and brainstorm on data formats and user interface capabilities to best meet those needs. We envision that the initial focused activities could perhaps provide a template for future stakeholder engagement in regional observing networks. Finally, in phase 4, we want to focus on building METS data analysis and user capacity. And an important challenge and opportunity to enhance the impact of the Marine Ecological Time Series is to build capacity for the data analyses and synthesis across time series and with complementary multi-platform observations to address spatial patterns of variability and change. This RCN's development of a fair METS data model framework will be critical in supporting these efforts to build capacity among emerging leaders in the oceanographic community and foster hands-on instruction, peer learning, collaboration. We hope that the RCN will be able to convene a METS data hackathon towards the end of the RCN. And that will be geared towards early career participants, students, postdocs, brand new faculty, using the existing high visibility Ocean Hack Week format. Potential hackathon modules may include statistics and visualization, METS data for modelers, computational methods to support data integration across shipboard, autonomous, and satellite remote sensing platforms. Really, the sky's the limit here. And this is really an exciting piece of this for me. I think this is a really, this place where data analysis, we've got oceanography and we've got the data science expertise, but where they meet in our capacity to analyze these data sets is really a growing area, and it's a very exciting one. So to get involved, you can learn more by visiting a website. We have just started an email list and a Slack workspace. So if you're interested in the email list, please let us know by adding your name and email to the Google Doc. The Slack workspace has not been activated yet because we haven't really started the real work of the METS data working group yet, but that will be getting started soon. If you want to join our discussion, please go to I think the link's actually in the chat, so you can get in there too and get into the Google Doc and add your ideas and suggestions. So thank you for your attention. And with that, I'm going to jump into Adam Shepard's pre-recorded presentation on fair data and controlled vocabularies. So just give me 1 second.
My name is Adam Shepard, and I serve as the technical director at BecoDemo. And today I want to talk to you about the use of controlled vocabularies and their potential applications to Ocean Time Series data. I want you to imagine that it's 1984. You're 16 years old, and you have a license to drive. You see, it's Friday night. Your friends are meeting their friends at their house in the next town over. But before all this goes down, it's on you guys to make sure that everyone has a good time. So you call for pizza and you're going to have it delivered to their house. You've never been there before. So you're placing your order and the kid who answers the phone is just a total dweeb. And the kid asks, so like, what's their address, man? And you answer sheepishly, 1428 Elm Street. And he answers, pizza in 30 minutes or it's free. Click. Now, with the food situation totally wrapped up, you're feeling a little bit better, and you head out to secure tonight's entertainment, a video rental. Now, on your way out the door, your friends say, hey, get that one with the cover, with the righteous girl, bodacious dude, the light beams flying everywhere, the one with the force, you know? And so with that rich description of a VHS cover, you head out to find that movie. But remember, it's 1984. And this is the time where video aisles at the video store were just cram-packed with stuff. And you know, you're just having a struggling time just trying to find this movie. So you're walking up and down the aisles looking for some force movie, and it's just taking longer than you thought. Yeah, pizza will be there soon, but you just happen to stumble across something. Mega Force. And you're thinking, righteous girl, bodacious dude, light beams, it's got force in the title. I mean, you're golden. Well, little do you know that this is the beginning of some most unfortunate events. You see that they don't know yet that you are totally clueless, that you have no idea what Star Wars is, but they're already bumming because when you ordered that pizza, you had no idea that there were 2 Elm Streets within the same delivery radius. Now, when I gave this talk in Austin, Texas, I was just shocked to find, well, actually delighted to find that there were 2 Elm Streets, 30 minutes apart in 2 opposite directions from Senior Pizza. So for these poor kids, you know, they're forgetting that the meetup spot is in the next town over. They've given the right address, but in a totally wrong town. So someone somewhere is enjoying your pizza because in 30 minutes, that bad boy was free. So you all are out of pizza. But you're getting back into your head, at least you got a movie, but it's not exactly Star Wars. You know, they're bummed, they're hungry, but they're your friends, right? So, you know, you pop on the movie, you take it out, and you're looking at the VHS player. Oh, but they have a Betamax player. You know, it's that other popular video cassette format at the time, but you got a VHS. And now Friday night is trashed. You know, what happened here? And it's really analogous to what we experienced searching and finding and then trying to use data in the ocean sciences. You know, with the pizza, you got no results because of an ambiguous address. And that ambiguous query, and oftentimes in ocean sciences, could just be misinterpreted at our data repositories. And with that movie Megaforce, you found something, but it was really not what you expected. And then finally, with the Betamax, you know, you did find something, but you just couldn't use it because it wasn't in the right format. You didn't have the right tools. So there's this emerging sort of data principle in the data realm called the FAIR data principles. And what FAIR, it's really just an acronym for Findable, Accessible, Interoperable, and Reusable. And I think what we're seeing in the data repository realm is that findability and access and accessibility of data, you know, has been improving, and maybe it's improving slower than we all like, but you know, we're still moving in the right direction. Yet, as we rely more and more on automated workflows and computers to help us with our analysis, interoperability and reusability are making science difficult and cross-disciplinary science near impossible to automate. So without progress, ocean data, including Ocean Time Series data, really risks becoming siloed, making transformative interdisciplinary research much more difficult than it should be. And so, you know, maybe the problem of scaling interoperability for these automated workflows, for this sort of transformational science that we want to do, is really, about the way that humans arrive at agreement. And I think the way that we arrive at agreement as humans slightly differs from the way that computers do that. But, as humans, given enough training and experience, hitting milestones of rigor and education really affords humans the ability to communicate with slightly different words while still arriving at the same understanding or agreement, if you will, as to what's being said. And computers really lack this sort of like same affordance of domain intelligent humans. So on the screen here, I've put together what Ogden called the semantic triangle. And I think it really drives home this difference between the way humans think and the way that computers process information. So for a human, words that refer to a real world object pass through our conceptualizations, so that when we hear a word like cat or gato or katze, we first picture a cat and understand what those words refer to. However, computers can only exchange symbols unless we teach them that a single symbol may have different meanings in different contexts. And so without these concepts, or some context for the computer to understand and reason that, the word katze or gato and cat all refer to different things, we need to train that computer to give it a conceptualization that all these different words, refer to the same real world thing. So when you see two pieces of information that look similar, a human may reason that these may very likely be the same data in different formats. So, looking at these two blocks of data, the one on the left is some personal information written out in English and XML. And on the right-hand side, it's that same information written out in Cantonese. So looking at it, a human can reason similarity because of the physical shape and the context clues in the address, like the number 1428, that infamous house number from our Friday night pizza excursion. But computers don't reason over concepts until they're given some form of artificial intelligence to do that. And here's where controlled vocabularies can really play a crucial role in helping computers reason that these two pieces of data mean the same thing. So even though the symbols used in these data are different, as the data holder, like a repository, for example, if we tell computers how to interpret these symbols, for example, specifying that they represent a schema.org name, a machine can detect, given that URL that we see, schema.org name, that those two labels are in fact the same thing. Similarly, if we say that the value inside one of those name attributes means the URL of my orchid, for example, the computer can then also reason that both the English and Cantonese symbols used to represent my name mean those two names are the same, which is really cool. So computers can only exchange these symbols. So we must have some way of teaching the computer various ways of interpreting these symbols. And this is something that works today. So like, this is nothing revolutionary. The major search engines have been struggling and wrestling with this concept for a long while and have come up with some solutions, and the broader community have come up with some solutions here. And so, for example, if you've ever Googled for hotel reservations, you'll notice that you can book a reservation right on Google without ever having to go directly to the hotel site. And this works because hotel sites have tagged their data and their services with URLs from a controlled vocabulary that tell search engines like Google how to interpret them. And this is an industry best practice backed by the World Wide Web Consortium back in 2017. They published the Data on the Web Best Practices. And you'll notice in the interoperability section, they've blessed this recommendation by saying that one of the major tenets of interoperability is to include the use of persistent URIs or URLs as identifiers for data sets, but also within data sets. And this is really key. When we're talking about agreement on identifiers within data sets for ocean sciences, that might mean agreement on what parameters mean, what methodologies are, what the instrumentation was used in the collection of that data set. And in that space, computers can then, take those URLs and really begin to understand what that data set means in the context of that data set, and understand that data sets that use URLs, in one repository might be the same as a completely different data set using those same URLs to describe those parameters and those instruments in another repository. But the use of controlled vocabularies is hard. And this is really just a socio-technical problem to solve. The technology's there. It's just like, who is the right person to apply these? And so, the burden doesn't necessarily have to sit and lie on the shoulders of the data collectors. And this is really where domain repositories sit in a sweet spot of being able to apply these controlled vocabularies as curators. And so here we're looking at a page at Bicodemo for a parameter on magnetic susceptibility. And I just want to highlight that, at Bicodemo, what you're seeing here is that, we're applying these sort of controlled vocabularies to our parameters in our instruments. And in this particular case, what we've done is sort of valued the colloquial terms or the shorthand that a project might use in describing their parameters or instrumentations. And so at number 2, you'll notice that's the supplied name for the particular parameter in the data set. And what we've done is we've mapped that to our vocabulary term for magnetic susceptibility. And then looking at point 1, we've mapped that to a broader community controlled vocabulary, so that data sets all around the globe that use that same vocabulary term can then sort of be interoperable with each other, so that all uses of magnetic susceptibility following this community controlled vocabulary can safely be joined. And this page is just showing the definition of magnetic susceptibility in this broader community vocabulary. So when in searching a repository, either term can be used. It could be, that term gato or cat or katsa, because these community vocabularies have been applied. And so in review and closing, I just want you to take away from this talk that we need computers to agree on the meaning of our data, to use symbols that computers can draw the proper context through these controlled vocabularies, and that really domain repositories sit at the sweet spot and are here to help do that curation for the submitters in support of cross-disciplinary discovery and investigation. Thank you.
Thank you, virtual Adam. Next, I think I'm going to, so one of my presenters is having a hard time joining. So I'm going to have, Nico, would you like to go first? Are you able to share?
Yes, I can do that. Sure, I can do that. I'll just try to share my screen then. Can you already see my title slide in the background?
Yes.
All right, that works. That's good. Okay, I just have to go to presenter mode. All right. So yeah, I'm Nico Lange. I'm a PhD student at the GeoMar, and I will give you a rather focused view on our envisioned data synthesis product for time series stations here today. So what I mean by focus is that I will not give you a general overview, but given the context of this meeting here today, I will rather focus on our approaches towards the vocabulary used and our metadata approach for this time series product. And first of all, a big thank you to all the participating sites and their APIs, which are listed here on the left, actually. And the sites are already illustrated in this title map. And as you can see, we're just talking about quite an international effort. And as many of you know, not uncommon for such international efforts is that the vocabulary used, as well as the the methodology used to obtain the actual data, differs in some cases from station to station. And actually, given quite long time frames for several of the participating sites, They even differ within one time series station. And this nicely connects also to Adam's talk, which you've just heard. And given this complexity for the pilot, we have decided to focus on biogeochemical essential ocean variables only, as defined by Goose and shown here in this table, with the ones marked in bold actually illustrating the ones which are measured by at least one of the participating time series stations. But as you can see, these are rather header names. So these are the actual variables we are targeting with our pilot, or for our pilot. So for oxygen, this is pretty self-explanatory. For nutrients, we are thinking about nitrate, nitrate, phosphate, silicate, and ammonium. For inorganic carbon, we're targeting the 4 subparameters of the carbonate system: dissolved inorganic carbon, total alkalinity, partial pressure of CO2, and pH. For particulate matter, we're thinking of particulate organic carbon, particulate organic nitrate, and particulate organic phosphate, and nitrous oxide and dissolved organic carbon are pretty self-explanatory again. However, especially with these abbreviations, even though some of them are actually the official chemical abbreviations, we already run into troubles because, just as with the talk from Adam now, not all of the stations use exact these abbreviations and have some other vocabulary used for the exactly same variables. And hence we need a more systematic scheme or approach. And for the pilot product, we have decided to use a centralized mapping approach where we map the individual variable names, so the individual vocabularies used, to the VOS scheme. The VOS scheme is quite an established one, which is widely used and accepted. Hence, that's why we've chosen it. And we didn't want to introduce yet another standard, which is clearly not needed. So this slide, tries to, in simplified terms, illustrate the centralized mapping approach with the bold marked names corresponding to the VOS names. And the other ones, clearly the ones which are used by other stations out there or data centers. However, also here, there are of course keywords hidden. For example, if we look at pH, pH is not always equal to pH. As you know, pH is measured on many different scales. And sometimes that is already included in the name, so that makes it a bit easier, but sometimes it is not. And before we combine data from different sites, we clearly need to know what pH we're actually looking at. And for VOS, for our VOS definitions, we try to convert or obtain the total scale data at 25 degrees Celsius and 0 pressure. This is actually just one example of where some keywords are hidden. And for this very reason, we have generated a metadata template, which this can be used to map between the different vocabularies out there and gives some additional information. So in column B, as shown here, are the VOS definitions written down. So the ones we use for this pilot product. Column C is reserved for the individual time series station vocabulary, but we further also want to map to other common vocabularies used out there, such as the CF conventions, which you'll hear more about from Fernando in a bit, hopefully, and also to other big data centers such as BioDC or Bicodemo clearly. So that eventually we have the user or we have clear information about the different vocabularies out there and can easily map, or the computer, the machine can easily map between the different vocabularies out there. And again, it's the nuances which do matter. For example, whether data is written in large or small letters actually matters. And also things such as what fill values are used clearly do matter when we want to have a machine to machine readable data set. And if we look more into depth of this metadata template here further for exemplarily given dissolved inorganic carbon, we are, for example, looking at row 102 and row 103. Also have to think about the quality flagging scheme applied to the individual data sets, as many schemes are out there and not always does the same number actually have the same meaning for the quality of the data. So we need to be aware of this beforehand, so that we're actually comparing apples with apples and not oranges after all. The second reason for this metadata template can also be shown here, or can also be seen here. We try to use this template also to indicate in how far the individual time series stations comply with the Bermuda workshop recommendations for time series station data. And for this very reason, we first of all in column B indicate the Bermuda workshop recommendations, and second of all, we ask for example, the type of instrument which has been used and some more detailed information such as position and accuracy, for example. Okay, and eventually we want to end up with a system as this. This is clearly only the vision. So we might not achieve this with the pilot itself, but this is our vision, so that we have a non-restrictive system, non-restrictive in the terms that we do want to obtain all the time series data which is out there. So that we pretty much accept most of the data which is given to us. However, we still want to indicate in how far these data from the time series station does comply with our metadata availability terms, does comply with the Bermuda workshop recommendations, and also does comply with our quality control mechanisms or consistency routines. Again, none of the data has to follow our recommendations, but we want to have a meaning or a mean of indicating and how far it complies with our recommendations to the users, and hence we apply this flagging scheme as shown here by the extraction system, so that the user in the very end can have a very flexible approach to what kind of data he's actually interested in, can exclude or include the data he wants to through this flagging scheme, and hopefully through a centralized synthesis system with ERDAP at its heart, we can then automatically grab the data from the individual repositories where it is archived, format it using our metadata template, and apply our flagging scheme, and in the very end provide a consistent data set consisting of several data time series stations to the end user in a fair way. Again, this is a vision, so we'll see how far we get with the pilot product for this. But right now, we're still collecting some metadata, and once this is finished, we at least hope to be able to provide a consistent data set to the end user for now. And with that slide, I'm already done with my talk, and thanks for the attention.
Thank you, Nico. I'm going to pass the baton to Fernando now, who's going to share some recent work he's been doing on the HOT time series.
All right, can you see my slide?
Yes.
Okay, good. All right, first of all, thanks Heather for putting this meeting together, and also for the invitation. It's always a pleasure to be part of this community and help the way I can. Also, thanks all the data managers and PIs, co-PIs on this meeting. All right, my name is Fernando. I work for the Hawaiian Ocean Time Series project, and my role here is to help the program with the data collection, data processing, data release of some biogeochemical and physical parameters from the station Aloha. And today I would like to share some updates regarding our proposal to the climate and forecast vocabularies. So we do have good news regarding these new standard names. Just a quick overview from the original data set from our program. It used to be about 69 variables. And from this data set, CF had published already about 23 standard names that we could use to point out, right? For example, dissolved inorganic carbon. Carbon would be pointed to CF as small concentration of dissolved inorganic carbon in seawater with this particular canonical unit and with a generic descriptions of that term. So of course we were missing many variables, and we tried to fill that gap a little bit. So good news. Last year, we submitted our first proposal with 25 variables. It was submitted on September 16th, and it was already accepted. Well, it is accepted already. It is released, and you can check the announcement over here. And what that means to this community, you can start using all these variables over here. So I invite all the data managers, PIs, co-PIs, anyone using this particular vocabulary or these names, just start updating your NetCDF file, your metadata. For example, I'm gonna just give you an example. If you, let's say, want to use chlorophyll B, you can go on the CF table, search for that particular term, and you're gonna see the standard name with the description and also canonic unit over here. And we tried to match this parameter with an existent a parameter that is already available on the BODC. So for instance, you could check that parameter would link to this other vocabulary, other parameter. They just match each other, right? You can also search this same vocabulary, the same parameter, sorry, on the NERC vocabulary server. And the NERC vocabulary server will point to the climate and forecast standard name. The only difference here is that you have an identifier, and as Adam was pointed out, you can actually use this to refer to exactly the same standard name, right? So this would be very helpful for the community. So back to the presentation. So yeah, please go ahead and start using all this vocabulary. We can also update the definitions if people want to update. So the second batch proposal was submitted on October 16th last year, and it was about 19 variables. And from those variables, 14 were accepted this year. And 3 of them still need some discussion, and 2 of them were merged. And you can check the discussion happening on this issue over here. But it is already accepted, right? So right now we're just waiting for those variables to be released on the next version. And I'm not sure when that's gonna happen, but I'm pretty confident that's gonna be very soon. So stay tuned for these new variables over here. And the difference is we also submitted this segment trap variables units, sorry, not units, just the parameters. So yeah, this is exciting. Please go ahead, start using all these new standard names. And of course, we don't do anything alone. So big thanks to all these people over here. And yeah, thank you, everyone.
Thank you so much, Fernando. It's really fantastic, and I know backbreaking work that you've done there. So I want to open the floor temporarily for questions. I still am unable to get Justin Buck into the meeting, and I'm not sure why.
Here.
Oh, you are here now, but you're Fernando. Okay.
Ooh, that's exciting.
Oh, wow, you do. Wow, that's interesting.
I can change that.
Oh, that's why I didn't see you. Okay.
How's that?
Much better. All right, why don't you go ahead and share your slides then,
Sure,
Justin? Thank you.
Screen. Move that there. How's that?
Marvelous.
Perfect. Okay, I'm going to build on what everybody else has shown so far and effectively show a piece of work we've been doing on a project called EveryFair, which is working on effectively making the European marine research infrastructures fair. And it's a vast project, many COIs and many PIs, but I'm going to focus on the marine side of EveryFair. I'll give a brief introduction to EveryFair, and then I'll also show what we're doing actually to make data discoverable and mapping across different vocabularies. So EveryFair is effectively it's a huge European project which is making the European research infrastructures fair, and this spans marine, terrestrial, atmospheric, and biodiversity. It's about building a community, but EveryFair is very much around making those fair and developing fair compliance services and linking Every to the European Open Science Cloud, which is the large computing infrastructure in Europe. So the goals of EveryFair, we effectively look where it starts on the data in terms of formats and the metadata around the data, then go into the metadata around that data, and then work on access services, and then effectively user surfaces. And I'm effectively, the work I'm going to show you is somewhere between stages 3 and 4 of this work. And this is effectively work that's done for the marine domain. It's split into little subdomains, and we're working across EuroArgo, which is European component of Argo, EMSO, which is a European component of ocean sites, CDataNet, which brings together, I think it's nearly 30 data centers in Europe for marine data, ecos, which is the carbon research infrastructure, and LifeWatch, which is the biodiversity, which is connects to OBIS in Europe. Started with gap analysis, which we completed, and then we worked on common vocabularies for the variables, and then we worked on common standards for the metadata and common standards for what we call advanced metadata, and then effectively developing basic services and also working open licenses. So that's a broad overview of what EveryFair is doing. The bit that I really want to show you is what we've been doing on using smart semantic mappings across the marine networks to enable discovery and the access of the data. And this is primarily the work of Alex Kokanaki and Gwen Ronquafe, and I'm project manager on this work here, and I'm merely the presenter. So effectively what we've got at the bottom here is we have our different marine RIs. Each of those has an ERDAP server on top of them, and each RI at the bottom here has a different vocabulary used to describe their data. So R03 is the Argo one with things like PSAL, temp, doxy, for example, in terms of what's called in variables. EMSO is using P01 and also P09 vocabularies, ecos P01, CDataNet P01, which you've seen in previous ones, and LifeWatch is S25, which is effectively the species reel, which we have in our servers. So effectively, the user comes along and asks for oxygen data. This comes to what we call an EOV broker, and I'll come back to it at the end, but this is basically Atlantis variables, and I'll come back to what we're actually going to do to actually bind it to the EOVs proper at the end. There's effectively a translation engine, which actually brokers that request using smart mappings, which I'll describe in a second. It then grabs that data, passes that data back, and the user can access that data. And it's using a vocabulary server and some effectively what we call a PEV ontology in between. So what we've done is we've created effectively what we call smart mappings. You can see P01 here, down here, which is the standard body vocabulary, which you've seen in a lot of slides before. But we've got mappings to many vocabularies. And one of the challenges we've found with this is actually how do we maintain those mappings as terms grow? There are, I think, over 50,000 entries in P01, and how do we maintain those mappings going forward? So what we've done is we've actually broken down P01 in its semantic model and effectively taken its properties. So the property of oxygen, concentration, in the water, oxygen concentration in the water body. So effectively, that could be a term. And then what we've done is we've broken it down into 3 more terms. So that means when you come along and select oxygen, we can actually go across all our terms and say, I want all the data which has oxygen in a term or oxygen in the water body without having to actually build those mappings manually. So effectively, it's a smart mapping service that exploits effectively a semantic model that underpins all of our vocabularies. So effectively what we have effectively the central variable oxygen. This gives a result which goes to this P01 term. It goes to this P01 term. And if you follow this map down, this gets us the Argo vocabulary here, gets us the ocean sites vocabulary here. Once again, ocean sites, Argo, ocean sites, and the P01. So effectively go back. You see all of these vocabularies here. So what we can do is by a central variable, and we haven't built all the mappings yet, but effectively we can actually query the different data sets to return effectively aggregated data sets. And I've an update on this work since I last presented it. I met Pierluigi, as he's on this call last week, and we're actually looking at how we can extend this and how we can connect this to the EOVs proper and bind it to the ocean decade, which effectively means that we actually have that discovery mechanism as part of the ocean decade going forwards. And that's all I have. Thank you.
Thanks, Justin. I do see Pierluigi's on this call, and I'm wondering if the two of you can talk a little bit more about this ocean decade connection and whether or not this is something we can use as our cornerstone for all of the, I mean, ocean decade has so many different data types and constructs, and I'm wondering how we can kind of merge all of that around a single. So
we had the good fortune to both be at the Digital Twins of the Ocean Summit last week. Had a rather nice, fantastic little reception afterwards. And we got to talk about this at length. And we think we can do the first bit with kind of a hack type working workshop with about half a dozen people. That would output a demonstrator and a proposal for the decade. And that proposal can then go up for the decade as a recommendation and then come back down and we can do a broader implementation. We think the first step is actually getting half a dozen people in a room, working this through to get a demonstrator and actually show how this will work. And then that will form recommendations which we can take into the ocean decade proper.
Yeah, if I may, Heather?
Please, anybody who wants to speak, please unmute yourself and just speak right
Right, because like there was this general issue with EOV data products that many people were producing them or calling them EOV products, but they were not endorsed by the Goose EOV panels, or they didn't even know these products existed. And you know, this is no one's fault. It was supposed to be a bottom-up process, and people didn't even know the panels existed. And you know, the sort of buzzwords got out there. But now we're trying to sort of structure that space a little bit more, such that at least with the biology and ecosystems group of the essential ocean variables, we're convening a data team to set the specification for how to properly project data into the global commons, so that UN decade partners and others can vacuum it up and know it came from whom, you know, in the right data formats, etc. So we're doing that, and this is also part of some of the larger digital coordination actions happening in the decade. There's a whole strategy thing there that we're figuring out. But one of the main things we're trying to do is to let people do what they do best in their own systems, so in their own observatories and their own institutes. But we set the specifications for them to project out the data they want to share to the commons, right? So I was talking to Doug a little bit. Oh, sorry, Doug Fields is one of our contractors, but you know, he's worked with Adam and they work on the same schema.org story. And we could do, as Adam showed in his initial slides, and there is no current thing for a time series, no current specification for the metadata profile of a time series. So if the METS-RCN would like to take leadership there, us on the IOC or the IODE side, would welcome that very much. And I think that would be a great output for the community, because there are certainly others. And that propagates very quickly through the member states and also some of the other partners that are plugging in to us. So that's just metadata level. It doesn't solve the problem about all of the data types, but it's a start, right? And I think one thing that we learned, Justin and myself, Adam hosted a workshop in Dublin some time ago. We have to get the standards themselves to start mapping sustainably. So like the NERC with CF, with anything else that's out there. Because once it's done on their level, then the user doesn't have to worry about it, right? So that they continually maintain it. But it's a tricky thing to maintain, and mapping can be very hard in semantics. So there's a bunch of strategic considerations to take in place. But the main message is, the more you get the data in order locally, and the more you are willing to have a flexible abstraction layer to project that out in various forms, depending on some external need, the better a position you'll be in. If you hardwire your systems too much, it's going to be really difficult to sort of keep up with things.
Thank you, Pierluigi. That's really exciting. And I think that this group has started a lot of the groundwork discussions on metadata. And we had that workshop in Hawaii a while back, and that was certainly one of our points of discussion. And if we can start to work together as a group to come up with some draft suggestions, we can utilize our networks and email lists to try to, get some backing for that, to vet those recommendations. I think that would be a really good step forward. We've got collaborations with large and small time series all over the world. And I think if we can get people on board to adopt some minimum set of metadata reporting standards, I think that that's doable and would be a big service.
We can go a step beyond. I think within METS, we have 3 or 4 of the most incredible time series in the world. And they're being marked up with the vocabularies that we need to actually exploit these mappings and these technologies. So I think within this, over the course of the next year or two, I think there is potential for us to produce demonstrators that can actually help other groups and other communities use these technologies and implement these technologies and actually get the benefits from them. So I think we can potentially go a step beyond recommendations to actually try to lead a bit and show the communities beyond the ones we're working with directly what's possible and how we can actually achieve this.
Actually, would everybody mind if you're able to turn on your camera so I can just take a group shot? I forgot to do this during Ocean Sciences, and I would just love to get pictures of everyone who's here, if that's possible. Thank you. I know I'm going to forget to do this if I don't do it now. All right, I'm about to take the shot, so everybody smile. Awesome. Thank you so much. Believe it or not, in these virtual times, that really helps. So there's a Google Doc, and there's already some really great stuff, great discussions kicked off here. So I want to invite you all now, because I know I've done enough talking, to take a look at that Google Doc and see if there's something that in particular, questions that you have or additions that you want to make. I see people adding to the Google Doc, which is fantastic. Also, remember to put your name in here if you want to be informed about activities. I don't send messages to this list every day or anything. It's like a once in a great while thing. So I will not spam your email box. Frank Mueller-Karger has suggested that we consider having a special session at the Ocean Best Practices Workshop in October as a stepping stone activity. And then we've heard from Pierre that there's a need for some time series metadata reporting guidelines. And I think this community is uniquely positioned to provide those. The METS-RCN leadership can certainly start the process and then try to propagate these to the broader time series community and get some feedback on those. But I'd love to hear what else you think we can be doing as we do this hard work of fair data practices, which is really kind of, the fair data components, that's going to be really happening throughout the entire duration of the RCN. I don't see us going in succession and doing that first and then doing the broadening community engagement and then doing the capacity building on the data analysis front. I see that happening throughout the duration of the time series RCN. And then these other things, these like the data hack week and the regional stakeholder groups, I see that those as specific activities that will be part of the RCN. And this was actually supposed to be an in-person workshop too, but COVID had other plans for us. So we've been doing most of the work so far virtually. But do people have other thoughts about where to go from here? How do we start this? It sounds like some really exciting developments that Justin and Adam and Pierre had these conversations at their meeting last week. Other thoughts?
I'm super keen to try something. I'm super keen to try making these connections, try starting to bind these things together. And I'm not talking about complex, here's a web portal that do everything that you need, but even if it's as simple as Jupyter notebooks that will go and poll the data from different places based on, say, oxygen was the example I showed, but I'm super keen to experiment and see what's possible and see where the blockers are, because we can work on all the theoretical models and planning the world, but until we try to do this and try to start to connect these things together, I don't think we're going to find out where the challenges are. So it might feel too soon, but I'm super keen to start trying to bind these things together or do discovery across data sets. I don't know whether I've stepped the right way, but I just feel that I want to try some of this.
I think there's real, I'm excited by the progress that's been made on both fronts here. You know, the being able to go through the complex hot time series data set that Fernando did and be able to put new terms in the CF vocabulary for these things, but also to be able to tie across different vocabularies so that, like you said, you know, each time series is doing their own thing and they're using their own terminology, but to be able to knit all those together out in data space and you know, not have to go through some process where we're forcing everybody to adhere to this vocabulary for that variable and this vocabulary for that. The opportunity to do the types of things that you showed, Justin, is really exciting and probably ultimately more sustainable in the long run than getting everybody to agree on one approach or one, you know, map everything to this vocabulary for dissolved oxygen, map everything to this vocabulary for, go ahead, Ben.
Hi. One quick remark. I think it's great to see how things are coming together, but just to Justin and Pierluigi, for the working group, one thing that would be really nice to include as well is like the step of the data lifecycle for the individual data sets, because having just the term is not enough, because you're going to have so many different overlaps that some is automated QC, is raw data and so on, and that will be difficult to pull things together because suddenly you would end up with 5 times salinity or 5 times temperature, because data streams are divided between the different networks. So I think that would be something to maybe include in the future as well. You look confused, Justin. Okay.
I'll just, yeah, starting in the chat. No, I agree, because it's the provenance metadata that you need to actually give you that, particularly carbon, in particular carbon data.
Oh, I see some notes here in the chat. Lots of action in the chat.
Yeah, just writing some notes down on that issue also. I hear you, Benjamin, with that, because indeed things change a lot, and there has to be agreement at the level of the people who are running the vocabularies or ontologies or what have you, right? That they agree with that mapping and they will sustain it, right? When that's done, then the community knows that there's some place that they can go to and see what is the authoritative crossover with qualifications, because it will never be perfect. You know, there's always leaky semantics around that. Some things are very sort of done in different ways. So the standard that I shared in the chat, this SSSOM, is how we're doing this with some semantic services that also allow us to qualify just how accurate that mapping was. And right now we're working with some of the biodiversity standards communities, so the Genomic Standards Consortium and also TADWIG, with sets Darwin Core, to create such a mapping for their keys. And again, the executive board of TADWIG have agreed to maintain it. GSC's board will vote on that soon. It looks good. But that's really where we want to move, because then a user just has to point to that mapping to understand how to convert from one to the other. They don't have to sort of figure it out on the fly, because some of these things take some deep kind of historical knowledge to understand why something is the way it is. So we want things to be a lot more nimble. We don't want it to be sort of like, okay, everyone has to use this thing, because it may not be fit for purpose across the board, right? People have different needs and they have different vocabularies. But eventually, at least there's a common talking point that we can have those hackathons, we can have those meetings like that Adam put together in Dublin, and we can actually, actually start to converge. But we need something common to talk about first.
So, Pierluigi, is the next step from our perspective to bring together the work we've done and then bring it back to METS-RCN for evaluation and testing, working it through?
I think, on the vocabulary and semantic side, yes, like the stuff that is of interest to METS-RCN, we can focus on that for our sustainable mapping approach. Then we can basically have a crosswalk between NERC, so thesaurus level SCOS resources, to OWL stuff like ENVO, or to stuff like the CF names, structured names, right? Once we do that, we're kind of making, because they all do slightly different things, those different resources. So that would be very valuable if we can get agreement there. On the other side, in terms of sharing the metadata and defining the minimal time series data package, that would be like collaboration with Otis, and METS-RCN can take leadership there. So they would come to us and say, we as a community of time series experts in the marine realm believe this is the minimal metadata package that is needed to share data effectively, this kind of data effectively. And we can implement that on our side. So 2 prongs to this, one focused on semantics, one more generic in terms of metadata sharing, just to sort of declare the community in the automatically indexed knowledge graphs that are out there.
That makes sense. Thank you.
What do you think we could do in the next? So Frank raised this idea about this ocean best practices session and having a time series session there. Could we do a demonstration like what Justin showed with a few time series variables in September? I mean, is that something that I don't have a sense of what's involved here?
If we have a small enough set of examples, and then we do what Justin suggested, we have actually like a hack meeting. So no presentations, nothing like that. We just sit down with the problem, come to some sort of solution, see how far we get. Then we might have enough then to actually present in other venues, right? But I strongly agree with Justin. In fact, that was my wish at this G7 meeting that Justin and I were at for the digital twin, that we just start doing stuff instead of talking about it. But that's good, because then it gives us something to talk about once we've actually done it, right? So I think Adam, Justin, myself, a bunch of others here for sure, scope the problem, come up with a minimal viable product as a solution, And then that can be spoken of if we get agreement, particularly if we get agreement from those people involved in running the sort of data exchanges.
Adam, you've been quiet. I don't want to put you on the spot, but if you have any comments on that, I'd love to hear them. Or Danny. Those are our two BecoDemo, and also we have Dana here from BecoDemo. If any of you have thoughts about the time series data sets.
I think Pierre's idea of working on the mappings at that level, I think is the right way for us to approach it, to work at something that works globally. So I would be in favor of exploring that perspective.
And I think we talked about starting with a use case that we tried to collect. I don't know if, having something concrete from one of the time series producers, or having a use case for pulling something out to discover would help here. I think we had a homework assignment where everybody was supposed to submit a use case of their particular flavor, just to grab onto something to start with.
Yeah, I think we had one. Actually, no, two. I think Al Pluteman and Raquel both had use cases that they shared. So those would be viable starting points, I think. I can't recall right now what they were, but they're in our notes documents from the RCN. Not this most recent meeting, but the meeting before, I think. We started jotting down ideas. I see people feverishly taking notes. This is fantastic. Any other thoughts, ideas, questions? We have about 10 more minutes. Dana, are you trying to speak? I'm not hearing you very well.
I was, but I'm not. Can you hear me now?
Yes, much better now.
Okay.
I was hearing little bits of you, but then now I hear you much better.
Yeah, so I wanted to ask Pierluigi, you mentioned sort of a core set of things that you wanted to present and say, here's what we need for Ocean Time Series. Is there any progress, or have people talked? Is there a general idea of what those core items are, or who's sort of leading that charge?
I'm sure there are some opinions, but when I was speaking of it, I meant, so our perspective from, I'm putting my IODE hat on, we're creating the templates based on expert input to then allow people to share their metadata about various things. So vessels, people, institutions, generic data sets, spatial data, etc. Then communities come to us and say, hey, we're the expert community on tsunami warnings. This is what our minimal template looks like. Can you implement that inside this global data sharing space? And we try to, using this very, like the schema.org approach that Adam is very familiar with. He leads a bunch of that activity too. So the point there was, we don't have a working group for time series. So if the METS-RCN would like to nucleate one, it's a nice way of announcing it to all of the member states that have then endorsed this approach, so that if they have time series folks, they see it there and they have a contact point. And they don't just see it, but they also encounter the data you're sharing through it, right? So that was the idea. I'll drop in the documentation to what I'm talking about. And it's a project that was set up from IODE. We've been running for a while, but it's now working, and we have I think 29 partners, a bunch of national oceanographic data centers plugged into from the Pacific, Latin America, Caribbean region, Africa. Those are 3 implementation regions, but we also have like EMODnet services plugged in. Some NOAA folks are also plugging in things there. And I think, BecoDemo could probably plug in pretty easily, actually, because, well, you have Adam, so you have the expert on this stuff. But what we don't have there is a specification for what a time series metadata package should look like, to say, hey, I'm a time series. I'm a data stream rather than a data set. You know, I'll update occasionally, that sort of stuff. We don't know how to do that. So we'd be really happy to work with you and then set that up and propagate that through our networks.
Actually, Pierre, that sounds like a really easy, low-hanging fruit thing to do for this group.
Bridge the
Okay,
semantics. Just to bridge the semantics thing too, you'll notice in those patterns there's a keyword section, right? So we're not restricting what people put in there, but we will text mine all of those keywords using a stack of vocabularies and ontologies, marking it up and then allowing people to plug it into their semantic systems. But if a community already has a good idea of the kinds of keyword preferences or IRI, identified ontology or vocabulary terms, you can suggest them to make that part of the exchange even more structured. So again, we're happy to work with you based on where you're at. But we're very keen to make sure that this is applicable across the world regions, right? Some with lower capacity. So we do take steps to make sure that it's quite lightweight at the onset, but indeed it is an avenue for development later.
Other questions, comments? I'm going to add this Ocean Info Hub to the Google Doc while we're. Well, it was fantastic to have you all here, and I feel like we've made more progress in the last 30 minutes than over the last year and a half. So thank you. It's been very challenging to try to do this work virtually and gather people. I'm going to be putting this recording of this meeting on the METS-RCN website. You'll still be able to access this Google Doc, so please feel free to continue adding to it. And all of the names that were added today will be added to the email list. And it looks like, Nico, you are going to share the template, the metadata template. So
Yes.
that's, we'll sort out how to do that, how to best do that to be part of this. Any parting thoughts before we have to end our time? Great. Well, thank you so much to all of our speakers and to all of you for attending. And for those of you who are on my METS data working group and leadership group, remember that we have a meeting on May 18th. I've already shared that agenda with you. And if you have additional thoughts after today's discussion and new opportunities that have popped up, please do pop those into the agenda or just send me an email. And hopefully after we've made a little bit of progress and maybe even started with some of these demonstrations that we've been talking about, we can have another one of these web meetings and start sharing this broadly after we've had our small gathering and played around with it a little bit. So thank you, everybody, and I hope you have a wonderful afternoon.
Thanks so much, Heather.
Thanks, Heather.
Well,
Bye, everyone.
Thank you,
Thank you.
everybody.
Bye.
Thank you. Get well soon.
Bye.
Bye, Raquel.
Thank you very much. Bye.
Bye, everyone.
Bye.